In today's lesson, we're going to be talking about graphing cube root functions. Last week, we talked about graphing square root functions, and I've drawn some over here. Remember, the square root function can only go in one direction because you cannot take the square root of a negative number and be able to graph its answer on the coordinate plane. Remember, it's an imaginary number, so we don't know exactly where that is. The cube root function is a little bit different because you can take the cube root of a negative number. So first, let's start by saying that the parent function of a cube root is y equals the cube root of x. So now let's fill in a table of values for x and y. We're going to start with 0, 0. So if x is 0, the cube root of 0 is 0. That's your starting point. The cube root of 1 is just 1. So 1, 1 is where you would go next. And then lastly, the next perfect cube would be 8. The cube root of 8 is 2. So the next point would be 8, 2. Now, this looks like we would go here and connect this. This looks just like our square root function. However, since you can take the cube root of negative numbers, you can also say you can take the cube root of negative 1. The cube root of negative 1 is negative 1. So negative 1, negative 1. And then the cube root of negative 8 is negative 2. So negative 8, negative 2. So now you see the graph flips and goes the opposite way. So this is what every cube root function should look like. Sometimes it'll be stretched out, sometimes it will just move up, down, left, or right. Now you guys are really going to like this one because remember last week we plugged in, or we substituted in all of our real numbers for the range. So we can write that it goes from negative infinity to infinity. Another way to say that it's all real numbers is to use this little symbol, or like a little parallel line here, and then you make an R. So this means all real numbers. But here's what you're going to like about the cube root function. With the square root function, you could not take the square root of a negative number, so there were special restrictions on the square roots. With the cube roots, you can take the cube root of positive and negative whole numbers. So you can take the cube root of all real numbers. Every single time you have a cubic root function, the domain and the range will both be all real numbers, or the range and the domain will both be from negative infinity to infinity, however you want to say it. In the parent function, the y-intercept and the x-intercept are both at 0. However, if we moved it up or down, those would change. And then the coordinates for the three major points, these are them in the table of values. So our first major point was the origin, which is 0, 0, and then 1, 1, and then, of course, negative 1, negative 1, and then 8, 2. Okay? Based upon what we know from previous lessons, remember we have this number in the front, the a, that tells you how to stretch the graph. The h value will tell you to go left if it's positive and right if it's negative. And the k value, remember, tells you to go up if it's positive or down if it's negative. Okay? Without graphing these, we just want to talk about the transformations of these graphs. So there's nothing outside. This 3 is just the root that we're taking. It's not going to make the graph stretch or shrink. This down here would make this graph stretch. So let's remember that for when we get down there. All that's in here is a negative 3, so it's just going to go right 3. This one's positive, so it would go left 4. This one has two things that are touching the radical. So the first thing it does is it's negative, so it flips. And then it's 3, so it would stretch by 3, the scale factor of 3. Go ahead and do these real quick. This last one has a lot going on. Okay, any questions, pause the video, call me over, and I will explain them to you. Okay. On the back, remember the domain and the range for all of these cubic functions are going to be all real numbers. So the domain will be all real numbers going all the way down. The range will be all real numbers going all the way down. Okay? All right, let me do first, I'm actually going to start with letter C. I'm going to show you guys how to do this visually, and then I'll show you how to do it in the calculator. Most of you will want to do it in the calculator, which is fine. Remember, here was the original graph. The original magic points here were 0, 0, 1, 1, negative 1, 1, and 8, 2, negative 8, 2. So your original graph will look like this, okay? This is not the graph of cube root of x minus 2. This graph would have to shift down 2. So I would take my origin and go 1, 2, down 2, and then I almost want to pretend that this is the new origin. If this was the new origin, this would be 1, 1, negative 1, 1. This would be 2, 8, and then negative 2, negative 8. And so my graph, when I shift it down, would look like this. So this is now that graph, okay? And again, domain and range are going to be all real numbers. Now, if you want to do this in the calculator, that's fine. I just have to show you where a new button is on the calculator. We're so used to doing square roots that's really the only root that's on this main screen here, because we use the square root function so often. However, the cube root is sort of hidden in here. So if you wanted to put in the cube root of a function, you would hit the button that says math, and then see where there's this little cube root. You're going to hit this. And so if I wanted to take the cube root of, let's say, 8, I would just do this, and the answer would be 2. So now I'm going to go to my y equals screen. Okay, I'm going to put in negative math cube root of x. Oops. And again, I'm just going to do the same thing I did last week. Go to the table. This one, there is no set domain or range, so you're kind of just going to have to scroll here and find some whole numbers. So I'm going to start with negative 8, 2. Keep scrolling. I found negative 1, 1, 0, 0, 1, negative 1, and if I keep scrolling down, I'll eventually find 8, negative 2. Now, these numbers all sound very familiar. These are the perfect cubes that we've been working with. And if you look, remember the parent graph just looks like this. So look at the equation. This has a negative here, which makes sense that it would just flip. Okay? So what's in pencil is the answer to this equation. If you guys want to go ahead and graph these, I'll do it with you. If you guys want to listen to some music while you're doing this, this is fine, but just check your answers on here. And then when we're done making these graphs, I'll give you guys your next assignment. This one might look a little bit weird, but you have to remember it's being stretched by 3, so it's really getting stretched out here, and it would eventually look like that on the other end. Again, domain and range for all of these, all real numbers. Okay, when you guys are done with this other worksheet that I gave you, 1 through 6, you're just going to go in here and graph these. On the back, you're just going to look at the function and then match the graphs with their functions. So it's really up to you. There's a bunch of different ways you can do this. If you want to do it visually, if you want to take these and put them in the calculator and then hit the graph button and see what it looks like, you can do it that way as well. When you're done with this, you're going to turn this in the blue basket. And let me know if you have any questions.